As a first example, let's see how to write all the terms in the expansion of a plus b raised to the power of 3. And to do this, let's quickly remind ourselves of the binomial expansion formula. Remember, that was a plus b raised to the power of n is equal to the sum from r equals to 0 up to n of the binomial coefficient nr times a to the power of n minus r times b to the power of r. Now, comparing a plus b raised to the power of 3 to a plus b raised to the power of n, we can see that the only difference is the fact that we have raised a plus b to the power. We can see that the only difference between the two is that we've replaced n by 3. And consequently, all we need to do to find all the terms in its expansion is to replace every instance of n we see inside the formula by 3. So that would look like this. A plus b to the power of 3 should equal to the sum from r equals to 0 up to 3 of the binomial coefficient 3r times a to the power of 3 minus r times b to the power of r. Okay, now to actually write all the terms, what we need to focus on is the actual expression that I'm currently boxing in green now. Now we need to rewrite this expression, replacing r by each of the values between r equals to 0 all the way up to r equals to 3. In other words, we're going to rewrite this expression, the one boxed in green, 4 times, and those 4 times would correspond to r equals to 0, equals to 1, equals to 2, and equals to 3. So let's go ahead and do that. For r equals to 0, 0 times a to the power of 3 minus 0 times b to the power of 0. Plus, for r equals to 1, 1 times a to the power of 3 minus 1 times b to the power of 1. Plus, for r equals to 2, 2 times a to the power of 3 minus 2 times b to the power of 2. Plus, the case where r equals to 3 times a to the power of 3 minus 3 times b to the power of 3. We now need to simplify all the powers or exponents that we see here, and that leads to the binomial coefficient 0 times a to the power of 3 times b to the power of 0, plus 1 times a to the power of 2 times b to the power of 1, and carrying on this way leads to... Okay, now we can still simplify this further. Indeed, an important thing to remember is that any number raised to the power of 0 is equal to 1. So this b to the power of 0 simply equals to 1, and a to the power of 0 equals to 1 as well. Another thing to point out is the fact that any number raised to the power of 1 is simply equal to itself. So when we see b to the power of 1, that's equal to b. And when we see a to the power of 1, that is equal to a. Keeping those things in mind, we can rewrite this expression as 0 times a to the power of 3 plus 1 times a squared times b. And we carry on. Okay, we're now at the stage where we've done everything we can without actually calculating the binomial coefficients. So we now need to do so. Indeed, we have 4 binomial coefficients to calculate. And luckily for us, there are some nice and easy tricks. The first of which is the following. The first and the last binomial coefficient will always equal to 1. And you can go ahead and check, but you'll see that the binomial coefficient 0 equals to 1, and the binomial coefficient 3 will also equal to 1. The second trick to keep in mind is that the second binomial coefficient, as well as the second to last binomial coefficient, will always equal to the power to which the binomial was raised. So in this case, 3. So we can go ahead and state that the binomial coefficient 1 equals to 3, and the binomial coefficient 2 equals to 3. And so Finally, we can write all the terms of this expansion and state that a plus b raised to the power of 3 equals to a cubed plus 3a squared times b plus 3a times b squared plus b cubed. And we're done. We've just written all the terms. Let's go ahead and look at another example. Say we have to write all of the terms in the expansion of a plus b raised to the power of 4. Well, once more, let's start by reminding ourselves of the binomial expansion formula. Remember, that was a plus b raised to the power of n equals to the sum from r equals to 0 up to n of the binomial coefficient nr times a to the power of n minus r times b to the power of r. And now we see that the only difference between a plus b raised to the power of 4 with a plus b raised to the power of n is the power. And so all we need to do is replace every instance of n we see inside the formula by 4. So that would look like this. This should equal to the sum from r equals to 0 up to 4 of the binomial coefficient 4r times a to the power of 4 minus r times b to the power of r. Now, to write all the terms in the expansion, we need to consider the expression I am currently boxing in green. And since the power to which this binomial is raised is 4, there will be 5 terms in this expansion, and each term will correspond to each of the cases where r equals to 0, to 1, to 2, to 3, to 4, and to 5. And the expansion itself equals to the sum of all of those terms. So let's go ahead and write that out. That would equal to the case where r equals to 0, that's 0 times a to the power of 4 minus 0 times b to the power of 0, plus the case where r equals to 1, that's 1 times a to the power of 4 minus 1 times b to the power of 1. Plus the case where r equals to 2, so that's 2 times a to the power of 4 minus 2 times b to the power of 2, plus the case where r equals to 3, so that's 3 times a to the power of 4 minus 3 times b to the power of 3, and finally we add the case where r equals to 4, so that's 4 times a to the power of 4 minus 4 times b to the power of 4. We now simplify the exponents a bit, which leads to 0 times a to the power of 4 times b to the power of 0, plus 1 times a to the power of 3 times b to the power of 1. And carrying on this way will lead to the following. We now have our 5 terms, and we still need to simplify a little bit further. Remember, any number raised to the power of 0 equals to 1, so b to the power of 0 equals to 1, and a to the power of 0 equals to 1, and any number raised to the power of 1 is equal to itself. So b to the power of 1 equals to b, and a to the power of 1 equals to a. So we can now simplify this further to write that this equals to 0 times a to the power of 4 plus 1 times a to the power of 3 times b plus 2 times a squared times b squared, and carrying on this way we find this expression. Okay, we're now at a stage where we've done everything we could without calculating the binomial coefficients. But we now have 5 binomial coefficients that need to be evaluated. And again, remember, we have some tricks here. The first and the last binomial coefficient will always equal to 1. So that's equal to 1, and that's equal to 1. The second trick, remember, is that the second binomial coefficient and the second to last binomial coefficient will always equal to the power to which the binomial was raised. So in this case, that was 4. So we can go ahead and write that's equal to 4, and that's equal to 4. So all we really need to do is to calculate the value of this middle binomial coefficient, 2. And I'll go ahead and do that in the lower left-hand corner of this page. So 2 will equal to factorial 4 over factorial 4 minus 2 times factorial 2. And that will equal to factorial 4 over factorial 2 times factorial 2. And that's equal to 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. And now we can see that this simplifies quite nicely. Indeed, the 2 and the 2 simplify, or cancel out, I should say, with the 4, and that leaves us with 3 times 2 times 1 over 1. And it doesn't take us long to see that that equals to 6. So finally, we can write that this binomial coefficient equals to 6, and we can state that the expansion of a plus b raised to the power of 4 is equal to a to the power of 4 plus 4a cubed times b plus 6a squared times b squared plus 4 times a times b cubed plus b to the power of 4. And so there we have it. That's how we can use the binomial expansion formula to write all the terms in the expansion of a plus b raised to some power n, where n is a positive integer. That's it for this tutorial, everyone. I really hope that helped, and if it did, please hit like on this video and even subscribe to our channel, because that really does help us. I'll see you soon.